Hello everyone, welcome to lesson 321. We're going to be focusing again on rewriting to solve and show equivalency. Our content goals today, we're going to learn how to rewrite and simplify rational expressions, and then we're also going to learn what a whole is. I know this sounds weird, but this is a new graphical property that we are going to observe on a graph today, so you can see what it looks like and what causes it to happen. All right. I know there's a third goal here. We'll just call that a mystery goal. I did not mean for a 3 to be there, so... But first thing I want to do before we go any further with these rational expressions is I want to talk a little bit more about what cancels and what doesn't. So when we deal with these rational expressions, right, we're always looking for things to cancel out. And in a fraction, when we cancel something out, we cancel things out where we have a common factor in the top or the bottom. Okay, and when they cancel and become 1. All right. So when we are looking at fractions and we're looking for things to cancel, we can only cancel out factors, and those are things that are being multiplied. So for instance, in this first expression here, many students are tempted to cancel these out here. Right, so you might say, oh, look, there's a 6 in the top, there's a 6 in the bottom, so there's a common factor, let's cancel them out. But the problem is these 6's are not being multiplied by something, they are being added to something. Right, so it's 6 plus 5, not 6 times 5. And it's 6 plus 3, not 6 times 3. All right, so if I were to cancel this out, right, if I were to cancel that out, then you would be saying that this expression equals 5 thirds. But we know that's not correct, because if I add the top first, right, so let's just say alternatively, let's say if I do 6 plus 5, we get 11, and 6 plus 3 is 9. And 5 thirds is not the same thing as 11 ninths. Those are two different numbers. If you were to put them into the calculator, you'd get two different decimals. Right? But 11 ninths is the correct answer, while 5 thirds is not, because you tried to cancel out two things that were not factors there. Okay, so make sure you are paying attention to the operation in between the things in the top and the bottom of the fraction. All right, now if I come over here, you'll notice it looks very much the same. The only difference here is I changed the plus signs to multiplication signs. So now the 6 and the 5, those are factors because they are being multiplied. The 6 and the 3, those are factors because they are being multiplied. And if I look in the top, I have a 6. And if I look in the bottom, I also have a 6. So in this case, the 6's would cancel, and we would get 5 thirds. Okay, so that is the big difference there, is that we're multiplying here, we're adding here. All right, and if I did this a different way, so for instance, let's say I didn't cancel out the 6's. Instead, let's say I did 6 times 5, I would get 30. And if I did 6 times 3, I would get 18. And then I have this fraction, but if I pull up my calculator here, and I did 5 divided by 3, notice my decimal number, and look what happens when I do 30 divided by 18. I get the same exact number. All right, so 30 over 18 would reduce to 5 over 3. All right, so in this case, it is okay to cancel out these 6's because they are factors. All right, now let's take a look at this one. This one's pretty intimidating because it's got a lot of stuff going on, but you'll notice, right, that we have these parentheses around things. And so when we see expressions that have parentheses like this, where we have multiple things being added together, but then they're thrown inside of parentheses, we can recognize that this parenthesis, right, this 6 plus 5 is being multiplied by this other parenthesis, 6 plus 3. Okay. Now we don't see a sign in between the parentheses right here. We don't see that. But when two things are next to each other in math, we get to assume there's a multiplication right there. So these are two things that are being multiplied, so the entire parentheses become factors. So 6 plus 5 itself is a factor. 6 plus 3 itself is a factor. And you'll notice I have a 6 plus 5 in the top, and I have a 6 plus 5 in the bottom, so we could actually cancel out those 6 plus 5's. Another way to evaluate this, since they're just numbers, is to evaluate what's inside of the parentheses. So for instance, if I did 6 plus 5, I would get 11. 6 plus 3 is 9, and remember, those were being multiplied, so we have 11 times 9, over, and then in the bottom we would have 6 plus 5, which is 11. And so you'll see these are factors, and we have a common factor of 11 in the top and the bottom, so those would cancel, and we would get 9. Okay, so in this case, it would be okay to cancel out those 6 plus 5s, because if I did it that way, we would still just have 6 plus 3, which is 9. All right. Now, since we're in algebra, we are dealing with algebraic expressions, not just numbers, right? So you'll notice the similarity between these two expressions here, right? So we have 6 plus 5 and 6 plus 3, and down here we have x plus 5 and x plus 3. All right. Now remember, a lot of students might be tempted to cancel out these x's, and that would not be correct for the same reason it was not correct to cancel out the 6's. Okay, there is actually nothing that we can do with this expression and the way it's written. There's nothing to simplify here. I cannot cancel out the x's because they are being added, not multiplied, with the other parts. All right, now I come over here, and again, we change, right, to multiplication. So the 6's here became x's, but we have multiplication. Now up here, it was okay to cancel the 6's, and down here, it would be okay to cancel out the x's. Because they are being multiplied, they are factors. So common factor of x in the top and the bottom, those would cancel, and we would get 5/3. Okay. This one resembles our expression up here. Again, the 6's have all been replaced by x's. All right, and just like up here, the 6 plus 5's, they were okay to cancel, so the x plus 5's would be okay to cancel, and we would be left with x plus 3. So hopefully that gives you a little bit more understanding and clears up some of the confusion with what cancels and what doesn't. And like I said, getting used to what cancels and what doesn't in these rational expressions, it's going to take a little bit of practice. Okay. So the next thing we need to talk about is the funny things that happen with the graphs of these rational functions. Right. So I took this function here, and I put it into function notation and I graphed it. And so this is literally a screenshot of what I got on my calculator when I graphed it, and this is the graph that resulted when I put it in my graphing calculator. All right, and you're going to notice here as I look through my table that we have an error going on here at -5. Okay, so there was an error that occurred. And the reason that that error occurred is because in the denominator of my fraction, if I put a -5 in there, we would get -5 plus 5, right? So we would end up in the bottom of our fraction. If I put a -5 right here, we would end up with a 0 in the bottom of the fraction. Okay, you are not allowed to divide by 0. In fact, if you want to add that to your notes, dividing by 0 is bad. Okay, you can't do it. It's not possible. We talked about it more at the beginning of the semester. We talked about why dividing by 0 is an issue, and we'll probably talk about it again in the future. But for this lesson, what you need to remember is that you're not allowed to divide by 0. The calculator can't do it, which is why we get this error in our table. So what does this error look like on our graph? Well, let's take a look. So here's my graph, and it's weird because this thing looks like a line. And if you trace it, you'll notice a little thing happens here. All right, you see this little gap that the calculator creates? This thing is called a hole. Okay, this is called a hole. And it represents a discontinuity in our function because we're not allowed to divide by 0. Now, you might remember back to a previous lesson where we saw the same thing happen with asymptotes. Holes are specifically created when we have the same factor in the top and in the bottom. Okay, so we see that error pop up as a hole. Sometimes you'll see that error pop up as one of those asymptote things that we saw at the beginning of the semester. Okay, so knowing that we have these holes, knowing that we have these asymptotes, sometimes we have to state what's called excluded values. So someone might give me this function and I'd say, oh, I can make this a little bit easier. I can cancel out those x plus 5's and I can rewrite my function as f of x equals x plus 3. But I remember from my original function that I had a common factor of x plus 5 in the top and in the bottom, so I have an excluded value of -5. So I can simplify my function to x plus 3, but I have to remember to state that I'm not allowed to use -5 in this function. There's a hole there. Okay? So whenever we simplify a rational function from now on, we have to think about what the excluded values might be. Okay? So let's take a look at a few examples. Okay. And I put our steps here, so when we get a rational expression and we're going to simplify it, we want to make sure that we are factored first. Okay, they're not always going to come to us factored. Sometimes they will, sometimes they won't. So if they're not factored, we're going to do that first. Then we look at the common factors in the top and the bottom and we cancel those out. And then we state the excluded values from the original function. Okay. So let's take a look at this first one, right? So we have, this is in factored form, right? So we see the parentheses around the x plus 2 and the 4x plus 1. We know there's multiplication in between these two things, so these entire parentheses become factors. And same thing down here, okay? So I'm looking for factors that are the same. So I see an x plus 2 and an x plus 2, so those are going to cancel out, and I'm left with 4x plus 1 over x plus 1. All right, now you cannot cancel out the ones here because those are being added, and you cannot cancel out the x's here because, again, those are being added. Those are not factors. So this is where we would stop. The only thing we could do is cancel out those x plus 2's. Okay, and then we have to think about our excluded values. Okay, so the way that we find our excluded values is we look at the factors in the bottom, and we're trying to find values of x that would cause either of these factors to be a 0. So one way that I can find them is by taking a factor, and setting it equal to 0 and then solving. Right? So if I solve this equation, we would find that x equals -2. So I would say, well, x cannot be -2. And then I do the same thing for the other factor. So x plus 1 equals 0. Solve. We would get x equals -1. So x cannot be -2 or -1. And again, the reason being is if I took that -2 and I plugged it in to this one, we would get -2 plus 2, which would create a 0. A -1, if I did -1 plus 1, that would create a 0 here. And it would force us to eventually divide by 0, which is bad. All right, we can't do that. We'd get an error. So we can use this simplified version of that expression, of that rational function, as long as we exclude these two values. Let's try it again. Okay, so now this one is not factored. Okay, so don't be tempted to go through and cancel out x squareds and x's. You can't do that because all of these things are being added and subtracted. First, we want to factor it so it looks like this. We're going to factor it so that we have our parentheses in the top and our parentheses in the bottom. So we want to try and make this look like this, and we'll see if any of those parentheses are the same so that we can cancel them out. So I'm going to start with this top one. I'm going to draw a box and diamond, and I'm going to factor real quick. Okay, so I put the x squared in the upper left-hand corner. The 16 goes in the bottom right. The -8x goes in the bottom of my diamond, and then I multiply to get the top. So we would get 16x squared. So I'm looking for two numbers that multiply to give me 16 and add to give me a -8. Okay, so I'm going to go with -4x and -4x. So -4 times -4 is +16. -4 plus -4 is -8. And then I'm going to work on my outside dimensions. So we'll have x, x, -4, -4. Okay, so we get x minus 4 and x minus 4 in the top. All right, so what we're hoping for is maybe we'll see an x minus 4 end up in the bottom. So I'm going to take this expression that's in the bottom of my fraction, and I'm going to factor it, just like I did the top. It's a good thing we've been working on these factoring skills. Okay, so we got 3x squared going in the upper left, -8 going in the bottom right, -10x in the bottom of the diamond, multiply to get -24x squared in the top. And so I'm looking for two numbers that would multiply to -24 and add to -10. So that's going to be -12x and +2x. That was a tricky one. All right, so -12 plus 2 is -10. -12 times 2 is -24. So that works. Like I said, you might trial and error a couple times when you do that, and that's okay. You just have to get used to it, and the more you practice factoring, the faster you get at it. All right, so now I have a 3x squared, so I know I need an x and an x, right, to get the x squared, but I also need a 3 on one of these, and I'm going to put the 3 over here because 3 goes into 3 and 12 nicely. Okay, so now if I do 3 times negative 4, I get the negative 12, and this would be x times 2 to get the 2x. So now I've got 3x plus 2 and x minus 4. So we do have a common factor of x minus 4, so those will cancel. And my simplified version of this rational expression is going to be x minus 4 over 3x plus 2. Okay, and you can keep those in parentheses. That way you're not tempted to try and cancel anything you're not supposed to. All right, so there's my simplified rational expression. Now I got to find my excluded values. So I'm going to go back to this one right here. This is before I canceled anything out. And I'm going to take each of these factors and I'm going to set them equal to 0. And then we would solve, right? So we would subtract 2 from both sides, so we get 3x equals negative 2. Then we would divide by 3. So one excluded value would have to be at negative 2/3, and the other one would have to be at positive 4. Right? Because if I solve this one, we would get x equals positive 4. So we can say this is our function, but we have these excluded values. Okay, we can't let x be these things. All right, one more and then we'll call it a day here. This one looks kind of tricky. I see an x minus 3 in the top and I see an x minus 3 in the bottom. I also see a 4, and that's multiplication right there, so that's okay, right? So these are factors, right? But this squared thing might be throwing you off a little bit. So to understand this one, you just have to remember what squaring something means. Okay, so I can say this is 4 times x minus 3 times x minus 3. Right? Squaring just means it's something times itself. So it's x minus 3 times x minus 3. So I could rewrite that like this, and in the bottom we'll still have an x minus 3. And since these three things are all being multiplied, they are all factors. So I do have a common factor of x minus 3 in the top and in the bottom, so those can cancel. And my simplified version would simply be 4 times x minus 3. But we have an excluded value from this guy in the bottom. Right? So if I take x minus 3 equals 0, we would find x equals 3. So 3 would have to be excluded from the domain. All right, guys, that's it for today. Give the practice problems a try. I hope you found this video helpful. Have a great day.